Alright, let's differentiate h of t is equal to a plus b over t plus c over t squared if a, b, c are constants. So the way we're going to differentiate this, we're going to differentiate this using the power rule. So once again, the power rule, if f of x is equal to a x to the power n, f prime of x is equal to a n x n minus 1. Okay, now you can notice here that this is there's multiple terms, there's 3 terms. So in this sense, we're going to basically be using the sum and difference rule of the derivative. Okay, so just kind of review in the previous videos where we actually looked at some of these differentiation rules, and specifically power rule in general. Okay, so if I was going to find the derivative of h of t, right? What I want to do here, just to make my life easier, I'm going to change all of these reciprocal fractions in the form of powers. So I can rewrite this equation, h of t, as a plus b t to the power negative 1, right? Plus c t to the power negative 2. Okay? Now we need to know here that I'm basically using the rule as x to the power negative a is equal to 1 over x to the power a. It's an exponent rule, so make sure you know this. And if I'm finding the derivative, h prime of t is equal to the derivative of a with respect to dt plus the derivative of b to power bt to the power negative 1 with respect to dt, or the rate of change of t, plus d dt c t to the power negative 2. Okay, so you're doing the derivative separately, right? I'm just using Leibniz's notation as well as Lagrange's notation. It just kind of shows my step process. Now here we have the derivative of a constant, which is 0. Okay. Now if we use power rule here, we get negative b. Okay, so you do negative 1 times b, so negative b, t to the power negative 2, right? You subtract 1 to the power. And then for the next term, we do negative 2 times c, so negative 2c, t to the power negative 3. Now if we only wanted to use positive exponents, this would look like negative b over t squared minus 2c t cubed. And that is basically your derivative function.